Alright, the hyperbola. It's our last conic section. We'll go through the definition, the different parts. I'll check in for some understanding. We'll talk about the standard form, but I'm really going to just keep it at 0, 0 for the hyperbola. We'll analyze a couple of equations, and then I'll show you a summary. Hyperbola is kind of like an inside-out ellipse, and where instead of having a constant sum of the distances to the foci, we have a constant difference. In other words, looking at the diagram, d2 minus d1, the absolute value of that would be constant. That's not terribly important to us, but it does show that the foci are important to the hyperbola, and that keeping in mind that each coordinate pair that's on the hyperbola is a solution to the equation. So the added parts here that we are somewhat unfamiliar with, we have something called a transverse axis. We have a conjugate axis, and you can see those definitions down here. And we have asymptotes passing through this rectangle that was formed from going A to either side, B perpendicular from that, we get this rectangle. And then when you draw a line so it passes through the diagonals of the rectangle, you get the asymptotes of the curve. So this hyperbola is going to come down, it's going to touch the vertex, and it's going to never quite touch that asymptote. They look like parabolas that have been turned sideways, or two parabolas a little bit apart from each other. It's not exactly the same shape, so they get defined differently. All of the same parts apply if we change this to a vertical hyperbola. If I say that a hyperbola is vertical, I mean that the transverse axis is vertical. You can't actually do this second one down here because I didn't give you that information yet. But you can answer the first one. Is the transverse axis horizontal or vertical if we have vertices at 0, 5, and 0, negative 5, 0, 6, and 0, negative 6? So in standard form, our equation has a minus in the middle, and it's equal to 1. A, B, and C give us pieces of information that we should be pretty familiar with. The relationship now is a squared plus b squared equals c squared, so it does look like the Pythagorean theorem. You'll know it's horizontal by which one is positive. So if x squared is positive, then it's horizontal. If y squared is positive, it's vertical. A is no longer the largest number necessarily. It's not always the largest anymore. So I'm going to give you a second to try to analyze these two equations. Similar questions to what you were asked for the parabola. Is it horizontal or vertical? Where's the center? And then I just want you to give me the A, B, and C values. That's the necessary information to be able to graph. Alright, if you want to see all of the information summarized together, then here it is. Keep in mind that I'm going to have it all centered at 0, 0. So H and K will both be zeros. That's going to simplify a lot. So pause this, jot it down if you want. Make sure you bring your questions for me tomorrow.